And welcome to the channel. In today's video, we're going to go over the basics of using a multimeter. I have right here my Fluke 115. It's a bit of a pricey meter for hobby stuff. However, I do electronics professionally, so it's handy there. So if you're looking to get a meter, you can get some pretty good deals on some very inexpensive ones. I've bought some in the past for $10. So they'll work just fine for what we're doing. So we'll get right into it. Multimeter, you're going to be able to check voltages. That's what the V is for. I know, amazing. The V with the wavy line, that's going to be your AC voltage. And if you hit the yellow button on this one, it'll give you frequency. Some meters may or may not have that. Voltage with a straight line or the dotted lines, that's going to be volts DC, and that includes switching voltage. And we'll get into that in another video, I hope. Right here we have millivolts, so that's the first three places after a decimal for millivolts. And default is AC or DC right there. Ohms, that's going to be a resistance. This is a beeper. We'll get into that for checking wires usually. We have a diode checker that may or may not be on some of the smaller meters. And then our last two are current. So let's start with the easy one. We're not going to do volts AC. For most hobby projects, you're not going to be using a whole lot of AC unless you're plugging into the wall. And really, for measuring that, it's going to be the same. You just switch it to AC instead of DC. And so most meters will have a little indicator of what you're in. So let's go straight to the DC. And the easiest thing to do with the DC voltmeter is measure, DC volts, which are handily provided by batteries. So I've got a AAA battery here, and those usually come in at about 1.5 volts. And so we'll go to our negative side with the black meter and positive side with the red probe, not meter. And we have 1.5 volts. That's a good enough battery. Then our 9-volt battery conveniently tells us that the negative is there and the positive is there. And I always figured that out, that the positive was smaller than the negative because you don't get as much out as you put in nature. There's some loss in there. That's how I remembered it as a kid. So we'll go negative and positive and 9.5 volts. That's a good battery. Also with the project, we have 3 AA batteries, and they're supposed to be 1.5 volts each. And we can actually check that to see if it's doing what it's supposed to by measuring right here where they connect to the board. If you've already done the project, then you remember having to solder those in. And we have our red and our black there. So let me swap the leads over. And we can check that right there. There we go, 4.7. And 1.5 should be 4.5. 4.7 is plenty good. So we're good there. So there's some basic checks. You can also use it, say, in this project, the LEDs coming on. We know it works. However, there's going to be some more to that in a bit. So there we go. We'll go black and red across that guy. There we go. I'll get my hand out of the way of the meter. And there we go. We can see that we're losing 1.2 volts across that resistor. And that's that current control resistor that we talked about when doing that project back on video 1 or 2 or 3 or something like that. We can go across this guy. Hopefully I can get in there. Let's see, put that onto color. We'll go across there. And let's see if we crank that up. There we go. I'm having a hard time keeping my fingers on it. So there we go. You really need a third hand when you're doing electronics. Okay, so there we go. We're cranking it up, cranking it down. You can see it changing on the meter. And you're going to have to take my word for it that the LED is changing as I crank it. So like that, as the voltage changes. So that's just the basics of DC measuring with a meter. Super handy, going to be the most common feature you use. Millivolts is when you get down into small voltages, like I said, 0.000. Those 3 digits are your millis. The next most common one you're going to be using is resistance. And it is not, in this case, futile. It's great for figuring out what value resistor you have. This one happens to be, let's see if I can get this thing to focus. There we go. Red, red, brown with gold. And I think that's a 5% with the gold. I can't remember. I'm going to do a video about resistor color codes. But red, red, brown is 220 ohms. So if we go across that, we've got that set to resistance. Let's focus back in on the meter there. Here we go. And we have 217, which is well within the specs of 5% for a 3-band resistor. Three bands plus the percentage. So that guy's good. This one, I'm just going to say ahead of time, it's a 10K, but it's a precision resistor. That's what we used in that part of the project right there. So if we go across that guy, oh, look at that, 10K, exactly what it's supposed to be. Now, when measuring resistance, you don't want to get your fingers on the probes. It will change the value. You can see there it dropped down a little bit. It doesn't seem like much, but in some cases it could be quite significant because your body is a poor conductor, but a conductor nonetheless. So if you put your fingers on the probes, you can see there I'm sitting at about 6-7 meg. And if you lick your fingertips and then put them on the probes, now we're down at 150K. So that's a very, very big difference between the two measurements. And that can interfere when you're checking resistance. Now, the next handy one that we have, and you'll probably end up using this quite a little bit, is the beeper. And that tells you if from one area to the other, if they're connected. It's very handy with a piece of wire. Now, a wire this size, you can tell, but if you have a really long wire, you can go from one side, get down there, to the other, and if it beeps, you're good. And you'll see that there's a 1 on there, and that's the resistance that it's reading. But if it's beeping loud like that, you know you have a good connection. It'll also let you know sometimes, let's see if this one does it. I don't know if it will for this guy. Yeah, it'll give you roughly about the right resistance, but it's not going to beep because that would be a problem. It's looking for shorts, and a wire is just a short from one place to another. In the past, older meters didn't even have that. All we had was the diode checker. But that can be a problem too because it can beep. You'll get a little beep like that when it goes across the resistor, and I'll explain that number here. Actually, I'll do that right now. We have here a diode. Focus up high. There we go. And so our cathode is right there with the line because cats are bad, and that's a whisker. And then there's our anode. So we know the line is going to be our negative. Let's see. Will it focus in? There we go. So if we put our negative there and our positive there, we get a single beep, and then you'll see on the meter it's 0.592. About 0.6. We'll just call it 0.6 for ease of use. Most diodes that we're going to be using in these projects will turn on at 0.6 volts. Now, if you reverse the leads, we get nothing. And that's what a diode does. It only works in one direction. There we go. And so that tells you that, okay, it's working in one direction and it's coming on at about 0.6 volts. That's exactly what we expect, and that diode is good. I haven't blown it up yet, but I'm sure I'm going to find a way to. And it does work with some LEDs. Take, for example, this guy. Here, let's get these other components out of the way. We'll take this guy. Now, our short leg is right there, so that's our cathode. And so that makes this the anode. And you'll see about 1.6 volts is where it starts to conduct. Now, we're not going to see any light with that. It's not putting enough power through to turn it on, but that tells you that it conducts. And if we go back the other way, where's my short lead? There we go. There we go. If we do it backwards, we get nothing. Oh, here we go. How about I make it so? There we go. And we get still nothing. So that's how you can check LEDs and diodes. And then that brings us to our last function that we're going to use. And again, it comes in AC or DC form, but checking our current. Now, current meters are a different animal entirely. And in fact, we'll take a look at this guy. If we go over to there, you can see how bright those are coming on. And hopefully it shows that that one's just a little bit dimmer. And that's because on take 87 for this video, I was showing what not to do by putting the ammeter across there and put the meter in current mode, making it ammeter, going across there, and then turning the diode on. And you could see there that we're down at 15, 16 milliamps. And it's negative because I have the probes backwards. But what that does is an ammeter is basically a short going across there. So it bypassed that resistor completely and it threw the full 5 volts onto that diode, and that caused some problems. But it's okay. It still works for now. We'll try and blow it up some other time. So if you need to measure current, you have to lift a component or have something in the circuit where it lifts up. So we're going to do this the caveman method. We're just going to go in and heat up this solder joint and then lift the component out. Now, this isn't the best way to do things, but a lot of times it's about the only way you can do things. And right now it's the only way I can do things because I don't know where my solder wick is. There we go. Now when you have that, hopefully you can see that well enough. There we go. That resistor's lifted up. Holding the meter on there with both hands is not going to be easy. So if you do get a meter, get yourself a set of roach clips or alligator clips, whatever you want to call them. Super duper handy. It plugs in there. We'll hook that onto the resistor right there. And then we'll go right there. So basically, we're doing the same thing now. If these were connected together, then it's the same thing. And that's essentially what's going on inside the meter. This circuit should work. And there we go. We get about 5 milliamps, which is actually a little bit lower than it should be. If you're troubleshooting yours at home, it should be about 12 milliamps. But because I blew this guy up trying to show what not to do, it's not going to be the same. Current will always tell you exactly where the problem is. But doing current measurements is very difficult because you got to lift the component out. So that's really about all there is to it with the meters. The other ones, we're not going to be using those that much. We might go down the road and measure some frequencies, but it's not that big of a deal. I have used the capacitor reading once ever in 30 years or more, so don't even worry about that stuff. If you get a meter, make sure it can do volts DC, resistance, and if it has a diode or a beeper on there, that'll be better. But really, these are going to be what you're going to be using 90% of the time. So hopefully that went well. Stay tuned for the next video. We're going to go into the circuit card, and if you built one and it's not working, we're going to go through how to troubleshoot it and see what's going on and how you can fix it yourself. So have a great day and enjoy.